Hello, welcome to our presentation on data flow diagram. My name is Christopher. We also have Mitch, who will be addressing the later slides in this presentation. I wanted to begin by explaining what a data flow diagram is. Data flow diagram is also known as DFD and will be referenced as such in this presentation. This slide visually demonstrates a structural and flow example of a DFD. The words within these geometrical shapes are placed here only for the purpose of displaying slide information, but we will get into a specific example of a DFD in the next slide. A DFD is a diagram representation of a system highlighting the storage, processing, and transmission of data through the system. This diagram can be a wide overview of the entire system or focused on a very specific process of the system. A DFD tracks the origin of data, how data passes through the system, how data is transformed or verified through various processing steps, and lastly, where the data is stored. DFDs can illustrate several properties, such as algorithms, modules, data, storage, transmission, and processing. But ultimately, each DFD will be made up of 5 primary components. These 5 primary components are first, interactors, second, flow, third, processors, fourth, storage, and fifth, trust boundaries. Now on to our example. Let me walk you through this example. We chose a specific process that occurs when a user modifies an existing item. We can see this case scenario within our application, our Pantry Pro application, which we are creating STD for in this course. Specifically in this diagram, the process begins when the user accesses the item in the application and then proceeds to modify the existing information. The data being passed from the updating and storage are plain text and item quantities represented by bool. These modified item details are then updated at the item detail class and sent back to the user by a retrieval process updating the item the user is interacting with. If wanted, you could really modify this DFD to add more steps in the process, and that would essentially make it more of a complex process, but for the purpose of displaying a data flow diagram, this will do for now. Our STD document will require several data flow diagrams to be created this semester. Each diagram will vary in depth level, but hopefully this part of the presentation has assisted you in better understanding what a DFD is and how to go about creating your own data flow diagram. Now, we'll go ahead and continue forward with Mitch to discuss the upsides of DFDs, when to use them, and the downsides.
There are a lot of great tools to help with software development project planning. In order to effectively choose the appropriate tool for each job, you need to understand all of the strengths and weaknesses of each tool. As far as DFDs go, there are a lot of fantastic reasons to use one when planning out your project. DFDs are useful for creating a map of your system that represents all of the storage, processing, and transmission of your information resources. They describe all data that enters and leaves your system and how and where this data gets transformed from one state to another. Doing so allows you to track the origin of data, how it is passed through the system, how it is verified, and where it is stored. This map allows you to see any security vulnerabilities at these junctions. When you're developing a system, a well-made DFD can be a critical resource to understanding the system, as well as figuring out where any bugs or vulnerabilities are. And as you fill out the DFD, you can see any discrepancies in the data where it either is not being passed to the right place, is not taking the correct form at the desired time, or it is not taking into account the user's interactions. This will help you identify and resolve any bugs or problems with your system. It also shows where potential attacks on your system could come from, which would then allow you to shore up these vulnerabilities with increased defenses and precautions, such as adding more verifications. DFDs can be useful for nearly any project, but they are not the sole resource you should be using, as they are not able to relay all of the information that your project needs to succeed. Some other tools should be used to complement your DFD. DFDs are useful for showing where data is stored in a system, but they don't accurately describe how data is stored. To address this, you should instead use UML diagrams that represent each of the classes you are using in your system, which would then show what kind of data is held in each of these classes and how it works. DFDs can give you a glimpse of how classes calling each other might work, but since the idea of the DFD is just to show the passage of data, it doesn't completely or accurately show how each of these functions in the system call each other. In order to represent that, a structure chart should be built. DFDs also don't show you how functions work. It may show you what data is sent to a function and what comes out, but the inner workings of a function are not described in a DFD. This would need to be represented by either a flowchart or pseudocode. Lastly, only functions that are relevant to the data are shown in DFDs. This would include functions that don't have any data, don't store any data, don't have any data passed to them, they don't transform data, they don't pass any data on, just any function that doesn't have any relation to data flow in general. This means that many functions in a system would not be present in a DFD. This can mislead those that are looking at the DFD into thinking the system works differently or is a lot smaller than it really is. This would again be a situation where a structure chart would be useful, as it would accurately show all of the functions in the program. This resource, Security for Software Engineers, that was written by Brother Helfrich, is a fantastic resource for learning all about DFDs and has some really great examples and explanations. If you want to know anything more about DFDs, I would recommend following this link and reading a little more about them. I hope that our presentation was informative and educational, and thank you for watching.